So here we go with our 22.1b notes. I'll try and make sure I'm staying on the screen there. I was requested to make videos because of AP tests. There are going to be people out of class and they need to see it. So, margin of error and sample sizes is a continuation of Friday's notes. Margin of error decreases as the sample size n increases. That's because it gets closer to the population size. So we often decide on an acceptable margin of error and then use that to find an appropriate sample size. Keep accuracy to at least the nearest thousandth within the problem, but then round your answers to the nearest whole number at the end. Okay, so you want to keep the decimal a little bit longer while you're going through it. We can't have a fraction or a decimal for the number in your sample. You can't interview 3.5 people. It's either 3 people or 4. Or you can use the rearranged formulas. So here are some rearranged formulas. Now, there is a whole proof as to how the margin of error ends up getting transformed. What it is it's basically taking your margin of error formula, plugging in how you find that, which would be your sigma sub x bar formula, and then doing some math to solve for n. So if you want to see all that, that's right here. Same with the population one. But I'm just going to jump right down to here to the simplified form. Now the reason why it's best for us to get n by itself is it's going to be helpful when we're solving. So the margin of error formula for means is given right here, and when you solve for n, you end up with z sub c times the standard deviation of the whole thing over your margin of error squared. That's our formula for when we're talking about the means. When we're talking about the proportions, it's a little bit more confusing, but we have p times 1 minus p times z sub c squared all over the margin of error squared. So let's see how that applies in a problem. A restaurant manager wants to know the mean number of seconds it takes to fill a customer order. He is aiming for a 90% confidence interval and a margin of error of 6 seconds. Based on past experience, he estimates the population standard deviation to be 21 seconds. What size random sample, or in other words, what n value should he use? Now, it doesn't look like he has anything to deal with proportions. It looks like he's dealing with means on these, especially since he talks about, where is it? He wants to know the mean number of seconds. That's where we're talking about means. So we're going to be using our formula right here. N equals z sub c. Now we've got z sub 90. Z sub 90, and if we look back at the previous days, we should be able to get our value. Z sub 90 is 1.645. We also need the standard deviation of the population, which he estimates to be 21 seconds. We need the margin of error that he's wanting, and that's 6 seconds. And let's see, I think that's all we need. So, to find our sample size, we take z sub c, which is 1.645. We multiply it by the standard deviation, which is 21. We put it all over our margin of error, which is 6, and we square it. So let's go ahead and look what that gets us. So let's see, 1.645 times 21 divided by 6, and then raise that all to the second power, and that gives me n equals 33.14. And again, since we're talking about n values, or our sample size, we have to have a whole number. So we're going to say the sample size should be 33 orders. That's how many, 33 orders or 33 seconds? 33 orders if he needs to see, if he wants to do a survey, he needs to check 33 orders to get a standard margin of error of 6 seconds. Okay, so we need to talk about random sample size here. A researcher wants to know the percent of teenagers in the United States who have a social networking profiles. It's probably 100%. No, I'm just kidding. She estimates that the population proportion is 50%. So we're going to be using this formula this time. She is aiming for a 99% confidence interval, or confidence level, so I need Z sub 99, and a margin of error of 4%. So Z sub 99 from the previous page is 2.576. You can see it up there. 2.576. We need our margin of error to be 4%. So we're going to call that 0.04 because we can never actually calculate with a percent. We always have to change it to a decimal. We want our p hat is going to be 0.5. That's from our 50%. And p hat happens to be the same as p, so that's helpful for us. So that also equals p. So let's plug all this in here. We have 0.5 times 1 minus 0.5 times Z sub 99, which is 2.576 squared, all over the margin of error squared, 0.04 squared. So, a little bit of calculations here. 0.5 times 1 minus 0.5 times 2.576 squared divided by 0.04 squared, and I get 1036.84 as my n value. So let's figure this out. A researcher wants to know the percent of teenagers. So what sample size? We need to use, well, I can't have 0.84 of a teenager, so I need 1,037 teenagers in my sample size, or in my sample. Okay, so your homework is worksheet 22.1b, as in boy. It's a worksheet. Give you a quick little shot of it. So for those of you that aren't here, if you want to take a screenshot of that, there's 1, 2, 3, and 4. There's 5 and 6. You can take a screenshot, or you can pause it. 7, 8. There's 7, 8, and 9. You can see all those. You can take a screenshot. And finally, 10 and 11. Okay? All right, good luck, and we'll see you back tomorrow.